All right, so I'm so sorry about that. So let's kick off with the class. So as I was saying, this is this 19th session of this program, week 10 in particular. We tend to be specific, and we are going to be stopping the assignments this week. So the assignment you'll be getting this week is going to be the last assignment for this program. So starting from next week, you're going to be getting your project details, and the project will be officially kicking off till the end of the cohort. All right. So just brace yourself. If you have not, someone is saying thank God. You are going to be having another phase of assignments, which is going to be your project, right? It's just that it's not going to have a tight deadline as the assignment. It's going to be um, spanning for 2 to 3 weeks, all right? After which, as I said, we're going to be having the project defense, and then we're going to round off with the with this cohort and move on to the next phase, which is the incubation period. So the incubation period is going to um, a specific number of persons will be sent email to join the incubation period. So what you'll be doing in the incubation period is to work with other persons in other track, like people in data science will work together with product managers, product designers, front end and back end and cybersecurity guys to build a project. We just rounded up with that of courts one recently where they had their presentation. So the core, this program will officially be ending this month, but then we will be selecting a number of persons based on your performance, all right, which would now be you will now have to be distributed to several groups and then join other persons in working on a particular project, right? So there is actually still a lot for you to do. So, but we've made a lot of progress so far, and I have actually checked the schedule, and I see that it would not be possible for us to do the stream leads that we talked about the other time. So you'll be getting materials for that in case you want to go further, right? And deploy the ML model you create in an app format. So I would advise you do that if you have the time, but it's not actually necessary. So that is just what's remaining for this particular cohort. It doesn't end here. All right. This is just a building ground, a building, the foundation of what you are going to be doing in data science. For those that are just starting out with this program, you've gotten a very solid foundation. So after you come out from this program, I will ensure that you don't stop learning. You continue with learning, right? You continue doing projects, working on projects, learning, advancing your skills because there are a lot of other things for you to learn. So you just take courses, you can take courses online and do just look for materials that will help you improve yourself and just build on what you've learned so far. So those are the things we'll be looking at. And I'm going to have a proper we're going to talk about this properly in the last class. So by then, you would have a better understanding of machine learning and how to work on projects. So I'm going to help. I'm going to talk about what you can do and how you can actually apply it or advance yourself if you actually want to advance um, to other advanced concepts or advanced parts in machine learning. So we'll leave that for later. But today we're going to be looking at, as you can see as the title of this video, data preprocessing. Right. So we've looked at the algorithms we need to look at so far. We've looked at linear, logistic regression, decision tree, KNN, SVM, and the likes, and all of that. Um, but today we're going to be looking at data preprocessing. All right. Please, can everyone else confirm if you're experiencing the same thing, or is just one person that is having that issue? So someone said my voice is skipping, so let me be sure so I can adjust my can adjust myself. All right. Okay. I guess it's just it's network. So I'll be sharing my screen now. Okay. So if everyone can see my screen clearly. All right. Okay. So today we're going to be looking at data preprocessing and what feature engineering. All right. We're going to be looking at data preprocessing and feature engineering. So this is something that you've had before. We've talked about this before. We talked about it during the introductory class, and also we talked about it when we introduced machine learning as well. So we're going to look at what data preprocessing is and some techniques we use in data preprocessing. So we're also going to talk about feature engineering and what exactly feature engineering is. So these are very two important concepts in machine learning. When you get your data, before you move on to build a machine learning model, you have to preprocess your data. You have to ensure that that data is well suited for the machine learning model. Remember, I told us that our algorithms, the machine learning algorithms, can't work with any other thing than numbers. So if your data is not numerical, you won't be able to use it. You won't be able to train a model on that data. So it's as simple as that. So the aim of data preprocessing is to actually shape your data, is actually turn your data into the right formats for machine learning or for training. So there are a few techniques that you need to know, and just it's actually just very simple, relatively easy. So we're going to look at how we can approach this. Okay. The reason why we've not done this before is because we are focusing on how to apply these algorithms before. So we use the data sets from sklearn directly. And as I said, yes, these data sets from sklearn are already what preprocessed. They are already ready for training. So you don't need to perform any other preprocessing on that data. Just take it, split it, train your data, and evaluate, right? But for a normal data that you encounter, you actually have to preprocess that data. All right, you actually have to perform some preprocessing on that data so as to have it in a format that will be suited for training. So let's just move further ahead with what we have today. So as you can see, the topic is data processing and feature engineering. All right. And now the outline, you can see we are going to we will actually brush over sklearn in D2 and then go on to the main thing for today. Okay, so look at overview of sklearn, data preprocessing and feature engineering, splitting our data sets, and building and evaluating your model. Okay, but the focus on today's class is data preprocessing and feature engineering. All right, so by now you already know how to split your data. You already know how to build a model and also evaluate that model, whether it's a regression model or what, a classification model. You know the evaluation metrics to use. All right, and by now you already know what sklearn is as well. So you don't, all these things are not new to you. So what we are going to be focusing mainly on is data preprocessing, but we'll look at every other thing here and how they relate to and how they interact with these techniques in data preprocessing. All right, so we're going to look at the overview or sklearn itself. All right, for the sake of those that probably didn't catch the class or didn't get the introduction we did to sklearn, this is another opportunity for you. But this is going to be a brief overview. All right. So as I said before, Scikit-Learn is the model or the library for machine learning in Python. All right. Like I said, you can call it either Scikit-Learn or what? sklearn. All right. You can call it either Scikit-Learn or sklearn. Anyone is okay. So sklearn is a free and beginner friendly Python library for machine learning. Okay. Are we having issues in the course? Please, if you are having difficulty with joining, just reset your network. If you can hear me, reset your network, and then try joining again. Okay. So yeah, let's just proceed. So as I said, sklearn is a free and beginner-friendly Python library for machine learning. You already know this. It provides a simple way to build and use powerful algorithms for tasks like classification, regression, clustering. Okay, so you by now you already know what classification is. You already know what regression is. You might not know what clustering is because we didn't look at it. I said clustering is a different kind of task in machine learning that uses what ML technique or what kind of machine learning. Remember, I gave us the different types of machine learning at in the introductory class where I said we have supervised, we have unsupervised, and we have reinforcement learning. Okay, so I told us that the supervised learning can be classification and regression. Why the unsupervised learning, one of the tasks that is being used in unsupervised learning is clustering task. So clustering is we have algorithms that we can use for clustering, which is not going to be we're not going to be looking at them, but can as well do your own research on clustering, right? Once you have knowledge on how to do classification and regression tasks, then this will not be a problem. So the reason why we're focusing on these two is because they are the common ones, commonly used ones. So although clustering is not that clustering is not used, but we want to focus on the ones that will be very much applied in your day-to-day task, right? Or wherever you see yourself. But that does not mean you shouldn't go ahead to learn how to do clustering. So clustering is just straightforward. If you can understand everything we've done so far, it's just the same process, okay? Just the same process. Just that clustering evaluation is kind of different. So let's not just go into that. So these are the things you can do in sklearn. All right, classification, regression, and clustering. So look at also the key features in sklearn. sklearn is easy to use. So I've mentioned this several times. sklearn is actually a very, very easy library for Python, for machine learning rather. So it's built in a way that anybody that is starting with ML can easily learn it and know how to apply it to any tasks that they are doing. Okay, so it's easy to use. So it offers a consistent interface for various algorithms, making it easy to learn and apply. So we also have preprocessing power. This is what we're going to be looking at today. sklearn actually performs a lot of preprocessing. You can use it for preprocessing, right? So sklearn includes tools to clean and prepare your data for data analysis as well. So we actually looked at EDA with pandas. We looked at how we can do some things like imputing missing values, duplicates, outliers, and all those things. sklearn can actually be used in performing some of these data cleaning and preprocessing. Okay, we're going to look at that as well. So sklearn can also be used for model selection and evaluation. We've seen this already. So it helps you to choose the best algorithm for your task and also evaluate its performance. So these are the core key features. These are the key features of sklearn. So by now you should already have idea on how to use sklearn generally. So we're going to add another one to the toolbox, which is data preprocessing. Okay, this is another revision of what we've talked about before. So remember we looked at the workflow, or we looked at the data science life cycle at the beginning of this program. So we also looked at that which pertains to ML, machine learning. Okay, so the first thing you do when you want to build a machine learning model, or you have a machine learning task to do, right? As we have here, you have to import your libraries. So this is the workflow. This is how you have it in your notebook, right? All your libraries, everything you're going to be using throughout the course of your work should be imported in a particular cell. So you should just arrange everything so anybody going through your code will see everything at a glance. It's not like you import one in this cell, so you now go to the 20th cell and import another. You remember that, oh, you need to use this particular function, you need to use this particular class, you now import it in that cell. No. Once you remember that you need to use a particular function or class or anything, object from sklearn, you have to go back to the initial cell where you imported the previous libraries and also import that as well. And you don't just import them randomly, you try to organize them, right? Remember when I was trying to import metrics from sklearn, I had to use a bracket, put them inside a bracket because I was importing a lot of them. Okay, so writing code is one thing, writing clean code is another thing. It helps everybody, right? For it helps you as well because sometimes you have to go back to your code to look at your code and all of that. If you have a clean and well organized code, you will have less headache navigating that code. Trust me, because you're writing a code now doesn't mean you are going to understand everything when you come back to it in a month's time, or I don't know, understand? So that is one of the importance of writing very clean and organized code. So that is the first step here. You import your libraries. So most of the time you'll be importing NumPy, you import pandas, and all of these libraries are associated with data analysis. Okay. So, but when you have come to sklearn, you have to import the specific thing you want to use in sklearn, as I've showed you before. Right. So after importing your libraries, the next thing to do is to what? Load your data. There is no machine learning without data. You can't do anything in data science without data. So it's important for you to know the data you want to use and import it. All right. So you usually import your data using what? Pandas. Especially when your data is an external data, right? In a CSV file, or it can be in any file format. It can be in Excel file, any file format, right? So you import it using pandas. Pandas support a lot of file formats. So we've been using just CSV, but if you have other formats like Excel, you can import it. If you have format like packets, and some other file format that you've probably not even heard of, pandas supports it. You can pass through them and convert them into a data frame, right? So we've been actually using sklearn data all this while. So today's own is going to be kind of different because we'll be using a data set that we'll be importing. So once you import that, you then move on to the next thing. So we usually have the EDA done, all right? If EDA is not requested, but you can do EDA for yourself to actually have an idea of what your data is, right? But normally you don't need it at the end of the model. If you strictly want to build a model, you can go on without it, but it's advised that you do EDA to have an understanding of what your data is and all of that. In fact, you should always do EDA, whether it is requested or not. Okay. So once you are done with EDA, then you'd okay, before EDA you have to clean your data, all right? So that is the initial cleaning step. Then EDA, then data preprocessing. So data preprocessing is quite different from is quite different from data cleaning. All right, data cleaning is just trying to um, remove inconsistencies and irregularities from your data set. All right, you're trying to remove all these things that makes your data dirty, right? All these inconsistencies, irrelevant data points, and all of that. Why preprocessing is actually pertaining to your ML model. If you're preprocessing your data, that means you want to try to bring your data to a particular format that will be accepted by the model, and it is also going to be efficient. Basically, we're going to look at some technique there. Although sometimes you include cleaning in your preprocessing step. Sometimes, most of the time, you include cleaning your preprocessing step. That's why I said if you're going to do EDA, you have to clean it first, do your EDA and preprocess. But if you're not doing EDA, you can just go straight from loading your data to then preprocessing it. So preprocessing would, in this case, it would have to do with cleaning and every other thing, right? That will bring your data to be free of um, any 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 inconsistency, right, or any irregularity. So that is basically what preprocessing is. As we are moving forward in this class, you would get to understand it more. So after that, then you go ahead to split your data. So as I told us, we will be always splitting our data into test and train. So we split our data into train and test data point and data set. So can someone just briefly tell us the essence of splitting our data? Why don't we just use the entire data set for our MM model? Why do we have to split our data? So I want to bring up the life of the class. So please let's respond in the chat. Why do we split our data? Why is it necessary to split our data? Why don't we just leave it in as the full data set and use it for training like that? So please you can respond in the class live chat. Okay, I'm seeing some answers here. So as to evaluate our model after training and check how well it generalizes on unseen data. We test our model with the data that has similar structure with our trained data. Yes, I like that answer from Shamsuddin and Sunday. We split our data so that the prediction model will have a similar but new data set. Exactly. Exactly. So I think we kind of understand and have an idea of what splitting is for. So that's actually fine. I think I'm satisfied with the answers. So exactly. So we split our data. So we have a different data set, right? That the model was not trained on. Because at the end of your model, at the end of building your model, you would actually need to use it in making predictions because that's the essence of building a model. And those predictions that you'll be making, they will be on new data set, real life data set, okay, that was not initially in the training set. So you want to see how your model will behave when it is deployed. So the way to test it, although the testing is not going to give you a very perfect reflection of reality, but it should give you an idea of how well your model will perform when meeting on scene data. So when you get your test set, train on train and then evaluate on tests. So that is basically what splitting is for. So you need to split, right, to be able to know how well your model will perform on unseen data. Okay. So once we split our data, we then select the model. So So we have a lot of models in we choose an algorithm, right, that will be used for training our model. So we have a lot of algorithm in sklearn that we can use. So we've looked at a lot of them already. So anyone that you want to use, you can just easily import it, right? We've seen how we can import some of these models, so you can just easily import them and then go ahead with creating or training your model with that particular algorithm. So by now you should understand how to do that, right? We looked at a lot of algorithms, and we've also looked at on how to train our model with these different algorithms. So after that, you then move ahead to evaluate your model performance. Okay, so you use metrics like accuracy score. Depending on the task you are doing, you just have to evaluate your model using the test data set. Then you can now start making predictions. So once you're done with your um model, you've seen that the performance is good, you're satisfied with it, then you can go ahead to making predictions with your data. So this is when you now have to deploy the model you've created or you've built into an app, right? So that is where Streamlit comes in. You can just deploy it, right? Embed it in the app, and then you can share the link to anybody. So the essence of the creating an app is just to make it user in the interaction user friendly. So someone can just easily look at the app, and then they'll be asked to input some features or some information. And once they give in some information, those information are actually going to be they have to correspond with the features in your in the training data set. Okay. So the model will use those features that the users have given in, and then pass it into the model and give a prediction, and the prediction will be shown to the user. Okay, this is the depending on the task that has been performed. So that is just the entire life cycle. Okay, if you're in a bigger team and you want to embed it into a bigger app, right, then you need to involve the front end engineers and the back end engineers. So you create the front end engineers will create the front end, and then the back end guys will work with you. When you are done with your model, you just have to send it to them, and they will find a way to embed it into the app. And then the app can be used for making predictions. Okay, so this is just machine learning in summary, right? So you should have a very good understanding of this workflow. Each of them have things that you need to know. Okay, each of them have things that you need to know. So today we're going to be looking at the pre-processing aspect of it and what is being done during pre-processing. All right, so let's just continue. Let's wrap up with sklearn generally. So throughout the past classes, we've looked at different modules. We've looked at different things, objects, classes, functions, data set from sklearn. And we've seen that when we're importing these things, we import them from a special module. We don't just import sklearn and then use sklearn dot something. We import it from a special module. So sklearn is a very big library, and it has a lot of modules, right? And each modules have their own functions and attributes and methods and all of that. So these are the common sklearn modules that you need to know. Okay, there are lots more, right? But these ones are the most commonly used. So you see that we have the first one here, sklearn the preprocessing. So we've not seen this before because we've not used it. So this is what we're going to be using in today's class, sklearn the preprocessing. So this will be used to import all the preprocessing attribute methods or classes that will be used in preprocessing our data. So we see this sklearn.model selection. All right, so this is what we're going to be using. I think this is where we import the train test split from. All right, so we have sklearn.metrics. This is where we import the metrics for either classification or regression. We have sklearn.data sets, which is used to get the different data sets that is built into sklearn. We have sklearn.pipeline. All right, we're going to look at this in the next week. So pipeline is actually a very, very efficient way of streamlining all the process from data preprocessing to model building. So once you see this pipeline, you actually love it so much because it simplifies the whole process, It's like if you are used to what pipeline is something that has pipe is something that has an opening at one point and an end. And in between the pipe, there might be a lot of things that is happening. Let's say you put in a raw orange or something raw, and then at the other end, you are expecting an orange juice. Right? That is what a pipeline is. A pipeline is something that has an opening at a point and an end and end on the other side of the pipe. So in between the pipe, there are a lot of processes that happen. So the same thing happens in this sklearn or pipeline module. We have a pipeline that takes in and that starts at a particular place and then ends somewhere. So everything in between are the different preprocessing techniques and the model building and all of that that will be happening. Okay, so you have more understanding when we look at using pipeline in sklearn. But it's just an additional thing to know. It's not a must know, right? Because you can do the same thing with the normal sklearn with other things. The other things that we'll be looking at, you can do exactly the same thing. But pipeline just tries to organize the code for you into a pipeline. So don't worry, you might not understand now, but as we proceed, you would understand better. So we have sklearn decomposition. So this is where you see things like PCA, principal component analysis. So we are going to look at a lot of other things too in the next 2 weeks. So PCA is actually a technique used to reduce the dimension of our data sets. Right. So what did I say dimension is again when it comes to machine learning? Can someone remind us what does dimension mean when it comes to ML itself and data set and all of that? What does dimension mean? Exactly. Exactly. Thank you, Abubakar. Features, praise, number of independent variables, patience features, sum of features. Exactly. So that is exactly what dimension. So dimension is corresponds to the features in our data set. So PCA is a technique that sometimes you have a lot of features. So it's to try to reduce overfitting or to prevent some things, you need to reduce the dimension, right? And a technique used for that is called PCA. One of them is PCA. So we can have that, you can get that from this place. So we're also going to look at PCA. So we have sklearn, the linear model. This is where we import our logistic regression and linear regression. We have sklearn.sbm, you know what this is for, right? We have sklearn.tree, you know what this is for. You have sklearn.assemble, you know what this is for, all right? So we also have for KNN, that is neighbors. So I want to ask a question now. How do we import SGBoost from sklearn? How do we import SGBoost from sklearn? I think we looked at SGBoost in the last class. How do we import SGBoost from sklearn? All right, thank you very, very much. That's actually just a trick question. You don't have SGBoost in sklearn, so you just have to import it on separately. You install it if you don't have it in your system, and then you import it directly from that SGBoost library. So, yeah, I can see that we actually know what we are doing here, right? So thank you very much for these answers. Right, so let's just move on. So that is it for Sklearn. Just a summary, just refresh your memory and your knowledge. All right. So now let's look at data preprocessing and what feature engineering. So these are new concepts, all right? So I'm going to try to just explain it. So we have data preprocessing, we have feature engineering. Okay. So before I even move on, please I want to just know, hope everyone is still following very well. We can still hear me clearly. I think we've all gotten these answers. Then yeah, thank you very much. You have to install SGBoost using PIP. All right, so data preprocessing and feature engineering. These are techniques in ML, right? They are used in machine learning. So data preprocessing is basically there are a set of techniques that are used to clean and transform our data into a suitable format for modeling. That is for training using our ML algorithms. Okay, that's basically what data preprocessing is, right? So the kind of things we can do there, for example, handling missing data. We can also do it in data preprocessing, normalizing or scaling features, encoding categorical variables, outlier detection, data transformation, even data splits itself is part of the pre-processing technique, right? Everything that precedes the model training, they are all referred to as data pre-processing. So even the train test split is also part of the data pre-processing techniques, okay? But we've looked at that already. But today we're going to be looking at some set of techniques that are used to work on the data itself to transform it into suitable format for modeling. Well, why feature engineering? Feature engineering is a technique basically, or are techniques that are used to create new features or modify existing ones to enhance model performance. All right. So in feature engineering, what you're trying to do, you're trying to work on the features. Either you're trying to modify those features, or you're trying to create a new feature from existing feature, right? So because features are the things that mostly determine the performance of your data set. So sometimes you need to create new features from existing features, and sometimes you need to modify a particular feature to change it and all of that. So all these things are categorized under feature engineering. So sometimes you can actually use these two terminologies like side by side, right? You can use them interchangeably. Some of the things that you do in feature engineering, they can be under data preprocessing, right? So data preprocessing is kind of referred to as a general umbrella term, right? So whenever we are mentioning data preprocessing, feature engineering techniques can as well be part of those things we do under it. All right. So sorry, so those are the things that you'll be doing under data preprocessing. All right. So yeah, let's just move on. So now there are two things that we need to look at. Right, two concepts we need to look at when preprocessing our data. So these are the things that you'll be using generally. Remember, we've already looked at how to train our model. So this is not going to look strange to you, right? It's not going to look strange to you. So let's just look at the screen here. So in sklearn, we have two things. We have what we call fit and we have what we call transform, right? We've looked at fit already. right? When we created our model and we trained it on our data, we are always using the fit method. SGBoost.fit, linear regression model.fit, this.fit, that.fit. So we are actually comfortable with the fit concept, the concept of fit in sklearn, right? So this same fit now is applied in data preprocessing techniques. So it is not just used for training. We can also use the fit method, right, in preprocessing our data. So there are some particular preprocessing techniques that while using, you have to actually fit it to your data first. And then you have the twin, which is called transform. So transform, fit and transform, they are two essential methods for data preprocessing. So this fit and transform, they are the main thing that you need to understand. You need to understand what these things mean. Right? The implementation is straightforward, but you need to understand what is happening. Okay? So we look at fit and transform. There are two essential methods used for data preprocessing, particularly when dealing with so this is just the what is happening behind the scenes, basically, right? So transformers are what enables your data set to be transformed using these processing techniques that we're going to be looking at. So they create a transformer. So these transformers, they're actually classes that learn transformation from your data. So when you call fit on your data, let's say you import a particular processing technique, right? And then you create an object from that particular preprocessing class. Then you fit it the same way you fit your model when you want to train a model. What happens during that fit is that the that particular transformation, that particular transformer, or that particular preprocessing technique that you've called, right, that you are fitting, it will look at the data. The argument the fit method takes is your data. It takes your entire data, unlike the model training, which take your S train and your Y train, right? This fit method during processing take your data itself. It takes the data and then looks at the data. That is what the fit does. It just looks at the data and learn how to transform that data. It doesn't transform it. Nothing happens during that fit. So it does the same thing when you train your model. It learns the pattern. When you train your model, right, the process of fitting your model is just trying to learn the best the relationship between the X and the Y, right? So it's kind of learning pattern. It's kind of a learning process. So the same thing happens in this fit method. It learns how to transform your data, right? So once it learns that transformation, you can now call the transform method after. So you say technique.fit, then you now come and say technique.what transform. So once you call transform now uses what was learned during the fit to then perform the transformation in your data. So that transform method, that is the point where the transformation occurs. That is when that particular thing that you want to do to your data happens. All right. So we're going to look at that. So then by then it's going to make much sense to you. But just follow me. Just follow the explanation here. All right. So let's just see what happens during the fit. I've just given you a general explanation. So as you can see, the fit method is responsible for learning the parameters necessary for the transformation process. So this is just basically what it is. Right? It learns those things that are necessary for transforming your data. It analyzes the data provided as inputs. So because you pass in what, as you can see here, fit takes in an argument, which is what data. So you pass the data into the fit, right? So it learns the data, it analyzes the data provided as input and calculates statistics. So all these things that you're saying, all the statistics that is what it is learning. It is learning just the things that are necessary to transform it. So those ones should not really be a point of concern. It should not be what you should be worrying yourself about. You leave that for sklearn to handle. So once you call the fit, it learns how to transform your data. All right. So You can see here these length parameters, they are now stored internally within the transformer object. So this transformer object is basically the object you've created, right? That you called with the fit method. So once you pass in that fit, your data to the fit, it's going to learn the pattern and just store the pattern internally. All right. So it stores it internally, and when you call your transform method, it takes that internal information about your data and then applies the transformation based on what it has learned. And the transform method actually it returns something, right? It returns a new data set that has been transformed. So we're going to see that in action in a few minutes. So the fit method doesn't modify the data itself, as I've said. It simply extracts the knowledge required for transformation. Right? So you can see here, just take note of this. The fit method doesn't modify the data. What the fit method doesn't modify the data. So which method now modifies the data based on what I've said? So can we just quickly answer that? If the fit method doesn't modify the data, what now modifies the data itself? So as I said this just a few seconds ago, I just want us to be on board. So please, can I get responses? If it doesn't modify data, what modifies or what method modifies the data? I need more responses. I need more of us to participate. I just want this class to be interactive because some of these things, if you don't interact with it, it might just elude you, right? It's not something that you might capture immediately. So these things we are doing are just to facilitate learning. Okay, so once you bring up your keypad or your laptop and type these answers, trust me, you are doing something to your brain, right? You're actually helping yourself to understand these things better. Okay, so it's very intentional. Me doing this is very, very intentional. So even if you already know the answer, please still type it out. Like still type it out is actually necessary. All right. So yeah, exactly, you all are correct. The transform method that modifies the data, not the fit. So the fit doesn't modify the data. It just simply understands the data. That is what it does. It learns from the data how to transform or how to apply the transformation to the data. All right, so now we have the transform method. What does the transform method do? The transform method applies the length transformation to a new data set. So I've explained this already. It utilizes the parameter length during the fit step to transform each data point in the input data. So it uses what was learned to now go all over the data point and transform each of them. Right? So this is what happens during when you pass transform to your data. So we're going to look at the examples basically, but let me just give an example. So for instance, if you are using scalar for standardization in the fit step, the transform method would subtract the mean and divide by standard deviation. So it uses a formula and applies it to your different data points. Okay, so and it will return or give you a new set of values, right? So the transform data is returned by the transform method. So whenever you use a transform, something that transform, you have to pass the output to a variable. You have to pass it to a variable because it is returning something. Remember when we learned about return what in function definition. So that return basically means that thing that is returning can actually be passed into a variable. So if you call a function and you can pass the output of that function to a variable, that means that function is returning something. Remember during our function class. But if that function doesn't return anything, even when you pass it to a variable, what is going to be the output? If you print out that variable, what will be the output? This is just a revision. Let me see if we still remember functions, how function works. So let me go again. If we return something in our function and we pass it to a variable, The variable is going to, when you print the variable, you are going to get the value of that return statement, of that thing that is returned. But if we are not returning anything, maybe we just printed out the value and we now pass that same function to a variable and we print out that variable. What value are we going to get? What is going to be printed on our screen? Thank you very much, Ponza. None. None. Like, this is very, very good. Thank you very. This is a very, very, very. It shows that we are conversant with almost everything that has been done so far. Like, now I can be confident that yes, we all know we all know what we are doing here, right? We've actually been paying very much attention, putting in effort to revise and also listen. So it is going to display none. These are questions that might come up during interview. Like, actually, technical interviews can ask this kind of questions. So these are Python basic questions. So the same thing happens here. The transform method, I told you methods are the same thing as functions. So when you call the transform method, it returns something. So that thing that it returns, you now have to pass it to a variable. We've been doing these things, right? But I've not actually explained it in this manner. All right. So that's just what I'm trying to do here. So that is it for fit and transform. So these are the main things, the things that you need to know, right, before using preprocessing techniques. Okay. So when do you use fit and transform? Now I'm going to, okay, we've looked at fit and transform separately. We can actually use fit and transform together as well. So fit and transform, we have different methods. We have fit method differently, we have transform method differently. We can as well use them together, right? So let me just go straight here. So we have .fit method and we have .transform method. So these are two different methods, all right? So we can as well use, we have another method which is called fit transform. So this third one is a different method that combines the two together. And I want to ask a question. Do you think anything will be returned in this particular method, fit transform method? Do you think any value will be returned? Do you think the transform data set will be returned here? If you use this particular, I'm just asking, I've not said anything regarding this final function. So I'm just trying to, based on what we've discussed already, I want to see if you can just apply it to this new function that we are looking at now. Do you think we are going to get any value returned when we use this fit transform method directly on our data? Exactly. Right? So because you already have the transform here, what this method does is that it performs the two processes at the same time. So it's just an alternative way of doing this fit transform separately. So it fits it and transform it at the same time in the same step. So that is just it about this particular function. So whenever you see it being used together, don't get confused because you can use it together, you can use it separately. All right. So let's now continue with this. So when do we use fit and transform? Right? When do we use it? So it's a common practice to use fit on the training data to learn the transformation patterns. So you then use the same fitted transformer with the transform method on both the training data and the testing data to apply transformation. All right, so I think you understand what is being said here. So when you want to apply the transformation to different data set, it's better you use fit, right, on the training data set, and then you can now maybe when you want to make predictions on the test, you can now apply that same transformation on the test data set using the same transformer that was learned from the training data set. So you use that particular object.transform, and it will give you the same thing, right? So, but when you use it together in your training data set, you have to use it together again on your test data set. You can actually, it basically cannot, you cannot use it repeatedly, right? The same way you use fit, you learn it. After you've learned it, you can now start using that learned transformation to transform different data sets. Okay, so depends if you are going to use that. If you are going to make transformation on different data sets, it's better you just fit it right separately and then use transform on the different data sets you'll be transforming. But if you're just going to use it once, all right, it's better you just use the fit transform. So as you can see here, why not use them together? sklearn provides a convenience method called fit transform data. This method combines both fit and transform into a single step. So it is particularly useful when you want to perform the transformation in one go, especially if you are only dealing with the training data. So this is basically what I explained like just a few seconds ago. So if you are not going to be transforming another data after, right, you just use fit transform immediately and you just use it to just transform that particular data set. All right. So that's it for that. This is a table that summarizes the key points. So you can see we have our method here, fit transform and fit transform. We have the purpose, we have if it modifies the data or not, and we have the output. So you can see fit here. Fit data, what does it do? It learns transformation. It learns transformation parameters from the data. Does it modify the data? No. What output does it get? None. Right? Based on what I just explained about functions, it does not return anything. So if you print out the output, it's going to give you what? None. So it just stores the parameters internally. All right. So we have the other method which is called transform. What does it do? It applies learned transformation from your fit to the new data. Does it modify your data? Yes. What does it give as outputs? It returns the transformed data as output. We also have the last one, fit transform from method. What does it do? It combines learning and applying transformation. Does it modify the data? Yes. What does it give as output? Transform data. Is that understood? So this is basically the summary of fit transform and fit transform. So this is what we're going to be using in transformation and data preprocessing. All right. So here are some common techniques, some common data preprocessing techniques we're going to be looking at. So first one, we have handling missing values. All right. So we're going to look at handling missing values. We are going to look at encoding categorical features, right? We have scaling features. We have scaling features. I think those are the things we're going to be looking at for now. So we are going to look at how we can handle missing values in sklearn using sklearn. We're also going to look at how we can encode categorical features, right, in sklearn using different techniques. We have label encoding, we have one-hot encoding, we have ordinary encoding as well. We're also going to use our scaling features as well, and we have some techniques under it. We have normalization, we have standardization. So we also have other feature processing techniques. We have feature binning, we have feature selection, feature transformation, dimensionality reduction. So we're particularly going to look at this dimensionality reduction, which is PCA, which I told you about. All right. So let's start with the first one. So we're going to start with handling missing values. All right. So let's quickly go to this, and then all right, so as I told you, we have to import libraries. So first thing we want to do here, we want to handling missing values with sklearn. So I'm going to show us how we can handle missing values with sklearn. We've seen how we can do that with with pandas. So this is like another way. If you've not done it doing with pandas, you can as well do it with sklearn. So sklearn has that's methods, right? That's functions, that's classes. So we have some that are used for handling missing values, and we're going to be looking at them. So the one that is being used for missing values in sklearn is what we call SimpleImputer, right? Using SimpleImputer. So you can see that this is in a class format. It has a which case is this written in? Which case is this written in again? Right. So based on the case, you can know whether it's a function or a class. So this is a refresher question. Which case is this particular SimpleImputer written in? I don't want to give you a clue so that you would not just know it. There are two cases that I talked about in Python. So which case is it written in? All right, thank you, Mohammed. Praise camel case, exactly. Yeah, camel case. And I told us that what classes are what written in camel cases. So whenever you see a camel case object in Python, it automatically means that that object is what? A class. So I just wanted to bring that to, I just wanted to remind us of that. So we have SimpleImputer, we need to import it. So we have to come here and say from sklearn.impute import SimpleImputer. So I have to come here and say from sklearn.impute import simple what imputer. So wait for it to run. All right. So yeah, once you import it, then you can now apply it. But first of all, we need to import our data sets. All right, so we'll just import pandas as PD. Okay, so import the pandas, also import numpy. So just import numpy because we'll most likely use numpy. So then we'll come here and import our data. So importing our data sets. So df equals to pd.read csv. Then which data are we going to use now? Let's see. Customer bookings, retail transaction. Let's see customer bookings. So another quick thing, I don't know if you've used it before, but let me see if I can. Okay, so another thing, just to help you ensure that you are importing your data correctly, right? Remember I told us that if you are doing anything in sklearn, and you want to, like, maybe you've forgotten the name, you can just press what tab. You can press let's say you are doing importing, let's say read CSV. Let me just come here and say pd.read. You press tab, all right? So it will give you options. So if I come and say read C, if you press tab, it will give you CSV, you press enter. It can also be done when you are calling a file, like you want to import a file, right? Ensure that that file you are trying to import is in the same directory as this notebook. So for example, now I want to import a particular data set called customer booking. So I come and say costs and then press tab. Because the file is in the same directory as my notebook, once I press tab, IPython, right, is going to search that directory with the letters I've provided, right, and give me options. So as you can see now, it's giving me an option that, okay, this particular file is in your directory. So do you want to use this? If this is it, you can just press enter. I think I have another one called diabetes. So if I click it, it's going to give me this, right? So this is another way to ensure that you are importing correctly. So you don't have issues like file not found and all of that. So in case maybe you don't, the name of your file is long, just type the first word or let's say you have C, press tab or customer. So to be more specific, you can just maybe type the two first letters, and then you press tab and all of that. So this is just an extra knowledge for you to just make your work much easier. So I'm going to do this, and you can see I've gotten my data set imported already. So now, if I'm to use the same pattern we used when training our model with sklearn data sets, we are with exactly this data. We are going to enter a lot of mess, right? We're going to enter a lot of mess because we have categorical data in these sets. So you can see we have a lot of them here. And what I said about ML not accepting numerical data is very true. So we will not be able to use it to train our model. So we need to ensure that every feature or independent variable is a numerical variable, right? So you can just quickly do our is my screen static? Hello, please, let's confirm. Someone else confirm if my screen is static. Someone just said my screen is static. All right, so please check your network. All right, so we will need to convert them to numerical variables, all right? So we already have some numerical variables here. If you come and say df dot what d types, you see we have objects. We have like five of them here, and we need to have every single thing in numerical value. So that is one thing that is being done in data preprocessing. Okay, but we're not going to do that for now. So what we are looking at now is what using SimpleImputer towards fill in our missing value. So let's now look at the data set to see if we have any missing value. Let's say it's NA. Okay, so you can see now that we have a lot of missing values. We have missing values here. Like almost all pictures have missing values. So we're now going to look at how we can use SimpleImputer to deal with these missing values. All right. So let's go back here. So the first thing that you can do when you have missing values, you can easily just delete them. So please give me a second. Give me a minute. All right, so we can either delete everything, right, removing our rows or columns, right? As I've said, I've given you reasons, or I've told you how to approach this, right? If you have a lot of data set and it not really impacts that, you can just remove it. You can as well replace the values, right? Replace values with the mean if it's for numerical values. So the imputation here is what we're going to be looking at. So for sklearn, we have the simple imputer, which can be used to fill missing values. So this simple imputer can fill this missing values. You can fill it based on mean, median, or mode. All right. So now we're going to see how to use it on our data set. All right. So first of all, let's see how we can set up our simple imputer. And before you set it up, you need to know your data set. So in this data set, we have what? We have, let's go back to, we have both numerical and data features. We have categorical features. So we want to work on the categorical or numerical features first, right? Because we can't apply the simple input applies the transformation to all the features at the same time. So let's just see what will happen if you just apply it to this data set as it is here. So I'm going to come the same way you create an instance of your model, right, of the linear regression model and all of the model we've looked at. The same way you create an instance of simple imputer. Whenever you have a class, you would have to create an object of that class to be able to use the functionalities. That is why we do these things that we are doing. So first thing you do is just come and say imputer, give it any name that you want, and come and say simple simple imputer. All right. So the simple imputer has a parameter called strategy. So if you create and if you do the shift tab, you see all these parameters. So it has a particular parameter called strategy. If you scroll down, you can read what the strategy means. So the strategy is what the imputation strategy, right? It's what you want to fill that missing feature or that particular missing value with. All right. So we have mean, we have median, we have most frequent, and we have constant. So the mean is what? It can be used to replace missing values using the mean along each column, and it can only be used with numeric data. So obviously, you can't use it with categorical data. Mean, median can only be used with numeric data, but most frequent can be used with what? Strings. So as you can see, it can be used with strings or numeric data. And we also have constant. So this constant, you have to indicate that particular value you want to. Maybe you want to replace all the missing values with 1. So you just say constant equals to 1, and you just indicate the constant value, and then it will fill every missing value with that particular constant. All right. So let's quickly look at how we can do that. So in this case, we want to fill in the missing values with the mean. So I'll come and say strategy, and I'll say mean. All right. So I've created the object. So let me come here and say creating a simple imputer object. So after this, what's going to be the next step? What's going to be the next step? Quickly, can someone tell us what's going to be the next step? What's going to be the next step here? Okay, exactly. All right. So exactly the same thing we do when we create a model instance, we fit it to the data set. All right. We fit it to the data set using what? The fit method. So the same thing is going to be done here. So after you've created the object, you then call the object, this imputer here, and say imputer dot what? Fit df. So now what's going to happen is that the particular fit method here is going to learn how to apply this mean to the data set. Right? It's going to what is going to happen here is it's just going to calculate the mean of each feature here, right? Okay, let's quickly see. It's going to calculate the mean of each feature and apply them. So that is what happens in this particular fit method. So, but it doesn't transform anything. It doesn't give you any value. It just learns the pattern of imputing the mean. So if I run this, you'll see that it's going to. There's something I wanted to point out before I go on properly. It's going to give us an error. Why? So can someone just tell us quickly why we are getting an error here? There's something I said before we did this. So can someone just tell us quickly why we are getting an error? Even before looking at the error, you should already know why we are getting an error, even before looking at the error message. Like I want us to just build that intuition, the ability to understand our error, right? So that we can be fast with debugging, even before looking at the error. So just mere looking at the code, you already know what the problem is. So what do you think the cause of the error is here? Exactly. Thank you. Aniche, Shamsuddin, Ponza. Exactly. Mohammed, you all got it. So we have what categorical variables in our data set, and we can actually compute the mean of categorical variables. All right. So that is exactly why we are getting this error. So if you scroll down, you will see that we have this error, value error, cannot use mean strategy with what non-numeric data. So before you apply this, you have to split your data set into the categorical and the numerical variables. All right. So I can just come here and say cat variables and say pd dot select df dot select data types and say include equals to np dot numeric exclude equals to np dot numeric. So let me see if that is going to. Okay, sorry, it should not be in string. What's string number? All right, so okay. We're going to do the same thing for numerical variables. Now conjugate dot select the types and say include equals to np dot what number. Okay, so now we're going to perform the imputation for the different categorical variables. So if I come here and say display cat variables. So you can see that it has automatically selected the categorical variables. All right. If I come and say display num variable, you can see I only selected. So now we can now perform this preprocessing on the categorical variable separately and the numerical variable separately as well. So that is why we have to separate it into these two. All right. So instead of running it directly on the entire data set, we can now fit it to what the numerical data set. I'll come here and say num variables. Okay, so if I run it, it should not give me any error. So you can see it has fit it. So we'll also come here and say imputer dot transform num variables. So you can see it has given us it give us an output. Basically the output is usually in numpy arrays, so you've gotten the numpy version with the replaced value, right? So each of these let me quickly see if I can get the dimension. So I'll say transformed, all right. I'm gonna say transformed dot shape. So you can say it's nine columns here. So if you check the number of numerical variables, the column in the numerical variables, there it is 9. So we can easily just use pd dot data frame to get the new data frame and do all of those things that you can use to generate a data frame. But what we have here, we're already getting the transformed version of the original data frame here that had missing value. All right. So that is it for the numerical variable. So let's do the same thing for the categorical variable. Let's come here and say num imputer. So it will be different because I'm using different strategies. Num imputer. Using simple imputer on categorical variables. So I'll come and say cat imputer and say simple imputer and say strategy equals to what? Most frequent. Right, most frequent actually. And be sure that I got the name correctly. Most frequent here. So say cat imputer equals to dot fit cat variables. Come and say transformed cat. Move this and come and say transformed num imputer the transform. How am I confusing this? The transformed cat variables. So if I run this transform. So what do we have there? Cat imputer, sorry. Cat imputer. All right, so we've created or we've actually used SimpleImputer to replace the missing value for both the numerical variable and the categorical variable. So you can now actually combine them, right? So you can come and say pd dot data frame and then pass the transformed cats. I can come and say columns equals to this is num actually. This is num, transform num. Thank you. So transformed. So it should now be num variables dot columns. right? So I think this should be how it is. So I'll have num. I'll just have to copy this here, come here and say cat. Come here and say cat. Come here. Num. So display. Come and say display cards dot head. Hope we are following. Hope we are following here. Okay, what's your columns? Columns should be not n here. N here. All right, so you can see that we've actually gotten, this is the transform data set, right? So I'm going to combine both of them now. So I will say pd dot concat, come and say cat and what num. I'm going to say axis equals to 1. All right. So you should see a combined data set here. Just come and say df 2. Okay. Let me just remove this. Then come here and say df2 dot head. So now we have the transform data set here. I will fill the missing values. All right, so I can check the number of missing values to see if anything has happened. I can say is n null and say sum. So you can see that we've actually removed all the missing values from here now to here. Okay, so some of you might be saying this is actually a very long process of filling this, but once you understand how to do it, you would actually enjoy it. And I think this is going to be your go-to strategy for handling missing value. You can as well handle missing value with pandas as well. So anyone that you feel comfortable with or you feel is better suited for what you are doing, you can just go ahead and use it. So this is just it. These are the steps. And one thing you need to know is that whenever you're working in sklearn and you're fitting something to a data and you are getting a transformation and you're doing transformation to get an output, any output you're going to be getting is going to be in numpy array. All right. So for you to get the pandas data frame, you just have to just do all this thing that we're done here. You just pitch the data frame on the array and then indicate the column to create a data frame. So you can just visualize it, but you can as well just take the transform output and pass it into your ML model straight up by concatenate it if there's a need for concatenation and pass it into your ML model. The ML model doesn't necessarily need a pandas data frame, right? An array itself is even more efficient, right? But it's just for visualization purpose and understanding your data better. So that is actually how we use SimpleImputer on our data set. Okay, so we can use strategy. The strategy we'll be using will be based on the type of variable we are transforming. Right. So let's just move to the next one because of time. So we're going to be looking at we've looked at SimpleImputer. We're going to be looking at encoding categorical features. All right. We're going to look at encoding categorical features. So I told you that our machine learning model cannot take in categorical data like strings and all of that. So you have to actually convert those categorical variables to numerical values. so that your ML model will be able to use it, right? So this process of encoding is what would be used to achieve that. So we have categorical variables in this data set. So we need to perform this particular data preprocessing technique. So for encoding categorical variables, we have three techniques. We have label encoding, we have one-hot encoding, and we have ordinal encoding. So let me just quickly point out the difference. So label encoding is used for target variables. As you can see here, label encoding should be used for the target variable. All right. So the target variable in this case is usually the variable you are trying to predict. So let's say you have a data set and the target variable has what? Yes and no, yes and no, yes and no, yes and no. So you can't just pass in that yes and no straight up into the ML for training. You need to encode it so it will give you what? Ones and zero, one and zero, one and zero. So what you use for that is what? Label encoding. Do you understand? So we use label encoding for that encoding. So let's just see an example here. Let's see if we have the label we have here is we have okay, this particular data set is not suited for ML algorithm. I just brought it up so we can use it for preprocessing. But let's see if we have any variable here that has just two values or any not necessarily two. So let's use this particular trip type. All right. So I'm going to come here. Let's just type out encoding categorical variables. So I'm going to just bring out strip type and say label equals to df2 trip type. All right. So label dot unique. So we have three. We have three values here. So just let us in this our label. So how we will do that? We first have to import the label encoding. Okay. We first have to import it. Right. Remember I told us about this preprocessing module. So this is where you import this particular part encoding technique. So I have to come here and say from sklearn dot preprocessing import label what encoder. All right, I'll run that, then I'll come here, I'll create an object and say label encoder and say label what encoder. So you don't actually need much parameter. There is no parameter to include in this label encoder. So you just create it and you go straight to say label enc dot fits, then put our label data here and then say encoded label equals to label enc dot transform, and I will say our label. So if I print it out, I just display. I'm not necessarily display, just print our encoded label. You can see that we have this is basically an array here. So I can convert it to a series too for better visualization. I'll just say pg.series and just say encoded label. So you can see it here. They've encoded the values here, right? If I say dot unique let's see label new dot unique. So you can see it has three values here, unique values, same corresponding to the three unique values we had there, which were round trip, circle trip, and what? Let me print out that other one. Come and see. it should be this label, right? Label dot unique. Come on, say print. So you can see we have round trip, circle trip, and one-way trip. So this is assuming the label. Let's say you have a label um, with three values, unique values. So you encoded it to what 201. So 2 corresponds to one trip, 0 corresponds to circle trip, and what 1 corresponds to what one-way trip. All right. So that is basically how label encoder works. So this newly encoded value is what we are now going to pass in into your model for training. So it's going to be your y variable. All right. So that is basically how you do what you do when you have a label that is in categorical form. So now there's another encoding technique that is called ordinal encoding. So label encoding and ordinal encoding, they're the same, they're almost the same thing. Just the difference is just that ordinal encoding has to do with features that has an order. All right. So for instance, let's assume your label has an order to it, like big, medium, small. Sorry, big, medium, small, or large, medium, small. There's an order to it, all right? It's not, for example, in this case, we have round trip, circle trip, and one-way trip. There is really no order, right? They are not, one is not higher than the other, or the other one is not lower than the, so they are just there with equal value. Why for something like this, we might have an order to a small, medium, large. So for this case, if your label has an order, you'd use ordinal encoder, right? You use ordinal encoder. So that is basically what we are going to use. So the step is still the same thing, right? You have to import ordinal encoder from sklearn.preprocessing. Sorry, give me a few seconds. Okay, so let's quickly look at how we can do that. So you have to import the first. Come here and from sklearn.preprocessing, import ordinal encoder, right? You run it, and then you can come here and let's say ordinal encoder. Come on, say ordinal encoder. So you have to specify okay, if you look at, let's quickly look at this. So you have to specify what we call categories here. So I always advise when you're using a function for the first time, you always look at this documentation here, right? So you can see now encode categorical features as an integer array. So let's look at this. So the category auto is a list that it takes in. So the default value is auto, right? So we have to specify the particular category, which is usually the label, right? So in this case, we have df2, or we just have to put label categories, right? Let's say okay. So come on, say odd encode fit. So let me just use fit and transform in this case. Can use fit and transform. I think we just need to put this here. Alright, so I'm gonna say df sizes should be trip type. So let me be sure I'm getting the right code here. Okay. Common so trip type. So transformed odd. Okay. Transform always can also pd.sys transform odd. Then we should have the of one-dimensional. Everyone is following, sure. So just follow how I'm trying to figure out these errors. It's part of what you also be experiencing. So the problem here is usually the dimensions. You have to ensure that you get the dimensions correctly, and also the notation or the variable names. So don't fall into error. So the error are usually trivial things. We have 5007.1. Let's see this here. New dot check. 5007. Okay. So let's see if we can shape. Transform out. Shape. So 5007. So yeah, this is basically it. You should get something similar. All right. So you can see in this case we use the ordinal encoder, and in this case we used what the label encoder. right? So you just leave it for the ordinary encoder to figure out how to let me comment. I think this category has to. So this category is just put it as a default. The default is auto here. So either you put it there, you leave it. But once you are just transforming a single variable, you just follow this step. So you get your y, and then you follow this step, and then assign the transform label as your y, and then you get your x that you've transformed already, and then split it. So there are actually usually more steps in processing. In preprocessing your data using sklearn. So, but with time you get used to most of these things. So this is encoding categorical variables, right? But what we've looked at so far is just how we can encode the labels. So, but we also need to encode the independent variables as well, because some of our independent variables will usually be in categorical format. So let's quickly look at that. We have our cat variables here that we looked at. Variables. So these are the categorical variables we have in our data set, and we need to actually transform them. So the method we use in transforming our categorical variables, independent features, right? It is called one-hot encoding, right? So one-hot encoding, let's see it here. Yeah, one-hot encoding is what we use for our independent features, right? So once you follow the same step as the other ones that we've looked at, you import one-hot encoder from preprocessing. So you come here and say from sklearn dot preprocessing import one-hot encoder. So you run that, you come back here and follow the same step. So say one-hot, come and say one-hot encoder. Then there's a particular parameter you always should put. So sparse is just to ensure that you don't have unnecessary data in the transformed data set. So you have to include this sparse equals to false, right? If you leave it, the default is true. So if you just leave redundant redundant values, just include this sparse equals to false. It won't actually change anything. It will affect your data, but it will help it to be more compact, basically removing the irrelevant values. So once you do this, you can apply it. Come here and say one-hot.fit transform. So we're using fit transform now to just be faster. So come here and say our cat variables. All right. So what is the problem now? Sparse output, right? Yeah. So one-hot dot fit transform with your categorical variables. So you can do the same process and you say one-hot encoder OHE and come and convert it to a pandas data frame. So say pg.data frame and say OHE, and then say columns equal to cat variables dot columns. All right, so you can have that, and you see new features or encoded features. You can say encoded features. All right, so what is the error now? Should pass, and this is in paragraph 5. Cat variables origin. Okay. Yeah, we can't use this here. So because the number of features that we are generating now is more than the number of features that we have initially. So we can apply the same number of column names to this new one. All right, so just you print this out, you'll see that everything here is in zeros and one. So now this is something you need to understand about one-hot encoding. What one-hot encoding does is that it takes every feature. For instance, let me print out the. Let's go back to this one we have here. So we have we have about 5 independent categorical variables, right? So for each of the categorical variable, it makes each unique value a column, and then creates a value for if the that particular value is present or not. So for instance, we have sales channel, right? Sales channels have like 3 unique values, which are internet. I think it has 2 more. So if you take internet, convert it to a variable, take the other one, convert it to a variable. So if a particular variable has like 10 unique values, it is going to form 10 new unique variables. And for each of the variables, it's going to give a value of true or false, which is 1 or 0. So if that particular this particular point is round trip, it's going to give us 1 and 0 for the remaining one. If the other one is, let's say, one way, it's going to give round trip 0 and going to give one way 1 and the other one 0. That's why it's called one-hot encoding. So only one of the unique values will be given the value of 1 and the other would have 0. So it's just like creating a new label. It's just like encoding a label, a binary label, right? So you do that for each of the unique values in a particular column. So that's why you see here that we have a lot of columns. We have about 919 columns. So we've basically created, converted each of the categories into columns. So we're having this number of columns. So I'm trying to see how we have that much column here when we don't have a lot of categorical variables. But let me see. Cat variable. Let me print out cat variables dot n unique. All right. So I think this is the problem. We have this route. So I'm going to have to remove this. Let's see, route. So I don't want to waste time on this particular data set because some of these features here, or this data set is not meant for machine learning itself. So I'm just using it to illustrate data preprocessing. So let me see route. Okay. Right. Okay, so we have to remove this particular variable. If I'm building an ML model, I would have to remove this variable because this feature, because it doesn't really play any role, right? So from the content I'm seeing here, it's most likely won't play any role, so I have to remove that. All right. So once I remove it, it's going to reduce the number of variables of new variables in the one-hot encoded variables. So this booking origin tool as well. So the ones we'll be focusing on will be sales channel, trip type, and flight day. So based on this categorical variable, if we convert it using one-hot, if we encode it using one-hot, we're now going to be having 12 new features, right? Each of them corresponding to the different unique values in sales channels, trip type, and flight days. All right. So that is how we work on independent features using one-hot encoding and one-hot encoding. All right. So you ignore this route here, you ignore this booking origin, but let me see if I can just remove that. So this is categorical. So we have routes, and we have what's the other one? Booking origin. Replace equals to variables. Come here. Is it something? So thinking something here. Route booking at phone access. Okay, access equal to 1. What's this thing saying again? Not found in access. So what exactly is it saying? Access equals to 1. Right, so okay, so this is what we're going to have now. You can see that we removed those two features, and then we have this output as our one hot encoded value. So this is what you're usually going to have. All right. I think there's a particular method or attribute you can use to get each of the encoded feature name, right? So you can actually see, let me see if I can get that OH print dir OH. So let's just see. Get feature names. All right, so basically we are going to use the get feature name for come here. Get feature. No, I keep forgetting this variable, this method names. Oh. So encoder rather, not one hot. comment columns equals to features. So this is just what I was trying to get. You would see that everything, I just wanted to do it so you would understand what we're having here. So you see that for the first one, we have sales channel, right? And we have the first unique value, which is internet. And for internet, we have ones and zeros. So if that particular observation is internet in the original data set, to give it one, and the remaining value is zero. So the second sales channel is mobile, and I don't know why this is. Okay, I think we are using the one with missing values here. So, but anyways, so this is basically what happens. So the second categorical variable is trip type. So you can see we have circle trip, and we have either 0 or 1 if the particular observation is a circle trip, or if the particular trip is circle trip or not. We have one way and we have trip run. So what this one hot means is that out of the different variable values in that particular variable, only one of them would have the one value, right? And the other ones would be 0, 0, 0. So that is what one hot means, one hot encoding. Okay, so we have flight day, we have the different flight days here. So only one of them would have one. So that is how you encode your independent features or variables before you move on to using them in building your model. All right, so you don't pass in them like this. And you can as well use the label encoder for it, but it's more advised to use the one hot encoding, right? So that is the standard while preprocessing your data. So the label encoding should be used for your label, and then but you can as well experiment on your own. If you use one hot encoding, you train your model, you get you see the performance and the accuracy and all of that. You try it again with label encoding or ordinal encoding. Okay, if your data set has categories, use ordinal, and check the performance of the model and see which one of these encodings actually give you a better performance, right? So there are different experimentation that you can do. So it's not just a one-way thing, right? So this is the different encoding method for categorical variables. So we have the last one, which is for numerical variable. So we call it the scaling and feature scaling. Feature scaling. So we have two methods here. We have the normalization, and we have standardization. Okay, so we're going to look at how we will do this quickly, and then we'll round up. So we've separated our variables into numerical and categorical variables. So for the numerical variables, we can see we have different values here, right? The reason for scaling our data is to bring all of them to be in the same scale. So for instance, you can see in this particular variable here, we have 262, a value of 262. And then in another particular variable, we have 7. All right. So these two variables, they're on different scale. So to ensure that, to make the model training efficient and faster, and also give you accurate results, you need to actually scale them so they will be on the same scale. So everything is going to be within a single range. All right. So the ways we can achieve that are through the standardization and the normalization technique. So now we're going to quickly look at that. How do we use standardization? We import it. So you come to this same place and say from sklearn dot preprocessing import standard scalar. All right, and say from sklearn dot preprocessing also imports min max num, min max scalar rather. So these are the two different imports. Min max scalar. So these are two different techniques for scaling our data. All right. So we'll do the same thing. We create an object for the two of them. So I'll come here and say standard scalar and say standard scalar. Come and say min max, and say min max scalar. So this is just out very, very simple and straightforward. So you can now pass in your data. So our data is what the numerical variables. So I can come and say standard scalar dot fit transform, and I'll put my numerical variables there. So if I run this, min max is not defined. Okay, this should be. So this is the output that we're going to get. You can see that we've scaled our data. You can see some one have minus and some just zero. So it's basically within a range, right? And now there's something you need to know. To select between this standard scalar and min max scalar. For standard scalar, if your data is normally distributed, right? If you've checked your data doing ED and you see that most of your data are normally distributed, you just go ahead and use standard scalar. But if your data is not normally distributed, it doesn't have a normal distribution, you use min max scalar. All right, so that is just the rule of thumb to follow generally. But you can use either of them and also experiment as well to see if it's going to impact your performance. Because at the end of everything, what you're trying to get is a very good performance, right? A model that will be able to predict with high accuracy, right, and minimize error. So that is it for this. So for min max scalar, you also come and then do the same things and say min max and then dot fit and dot fit and transform, dot fit transform, and then you see numerical variables. All right, so if you run that, you get an array as well. So you can now convert this. Because of them, I'm not going to convert this to a pandas variable. You can convert it yourself. So you would get everything aligned in a pandas variable, right? But with different values. So you've gotten a newly transformed data set that corresponds to the original data set, but transformed. So you can now use that and combine it with your encoded categorical variables, combine them and get your X, and then you get your label and assign it to your Y variable, and then you split it and then move on to train your data. So that is basically the process of that is basically data preprocessing in a nutshell, right? Although there are a lot of things to do here. If you have some other preprocessing techniques, right, that you need to perform on your data, like you would have to also perform additional steps. But generally, these are the three most common preprocessing techniques that you'll be performing during machine learning. All right, so we have your encoding categorical variable, you have your scaling, your numerical features, and you also have the imputation, right? So if you look at this, the notes here, you see that we just focused on those three, and then we have other ones which are not really okay. We'll look at feature selection. We'll also look at dimensionality reduction, but not in this class. All right, so towards after we are done, generally we are going to just look at them in case you need to use them and just improve your model performance generally. So that is it for data preprocessing. So feature engineering is a different thing on its own, which would require you to involve domain experts, right? Sometimes you might need to extract some features Like for instance, what we did the other time when we have to extract days of the week from the dates that we had in that data set. There's a data set we had, retail transaction data set, where you extracted days and months. That is what feature engineering basically is: generating new features from your already existing features, right? So that is just feature engineering. But generally, we consider all of them under data preprocessing. All right. So these three techniques, they just know them. You'll be using them almost every time you want to perform a machine learning model to convert categorical variables to your numerical features and then split and then train your model. So that is going to be it for today's class. Um, we've actually looked at a lot of things, and I believe you've learned more from the steps I've actually taken to solving some of the issue we encountered. Like I really like it when you see or you experience something like this because it helps you learn, right? It actually brings you to see that this is actually what will be happening and also show you how you can approach it. So that's going to be it for the class. We are going to be drawing the curtain here and taking one or two questions and calling it a day. So please, if you have any question, just indicate. I'm not going to be taking much question. Just answer, take two questions and then wrap up with the class. All right. Ojama, please ask your question and please be quick about it because I need us to wrap up in 2 minutes.
Okay, thank you, sir. Thank you for the class. My question is actually not for today class. It's more like an appeal. If you can take us on the process of uploading our code from Jupyter Notebook to the GitHub, because I had an encounter during the week where someone actually like, okay, since you are learning data analysis, can I go through your GitHub page? I actually have an account on GitHub, but nothing of data science that I've uploaded there. So I don't know if you can assist us with that, probably maybe in the next class or some other time.
Okay. Yeah, that's a different thing entirely. It's not so it's straightforward. Once you have a GitHub account, I'll send a link for that. Like, please, class rep, remind me again. Like, please remind me. I will send a link um, that will assist you in uploading your files to GitHub. It's actually also necessary because that is mostly where you have all your project and all of that. So please, class rep, just remind me either today or tomorrow. Thank you. So, last question. Ginika, please go ahead and ask your question. You can mute yourself and ask your question, please.
Okay. All right. Good evening. Thank you very much for the class. It has been very educating. I really learned a lot. I want to ask, there's something you usually press when you want to get the hint of something. I don't know. I tried it many times and it seems I'm not getting it.
Oh, that is you. If you want to get the hint, you use control, shift and tab, right? You make sure your cursor is on top of the text, and then press shift and tab, so it will give you that documentation. But if you want to do auto completion, you just press tab, and then it's going to give you options, and you press enter to select. So that is basically just it for that. So
Okay.
try it. You definitely should work. So that is it. Thank you guys for your time, and please just um, do the needful, right? Write out what you've learned from the class, and we'll be in the group and we'll be interacting and all of that. If you have any other question, please let me know in the Q&A group chat, and I'll attend to all of them. So thank you very much for your time today, and do have a splendid and a wonderful night. Thank you and good night.